So we've talked about ideas of central tendency, means, the mode, the median, and showed how this can be good. Knowing these ideas can be good to help us characterize aspects of data sets. And then we used positioning with quartiles and percentiles to further explore other ways of looking at data that can actually open up a better understanding of what's going on with the data set. But sometimes those ideas actually fall flat, and we need to go a little deeper in our analysis. So consider this idea. Suppose I'm interested in painting my garage, and there are two affordable brands of paint that I need to decide. I need to select one from. So I might collect some data concerning each brand. So I might be interested in how well a brand of paint weathers. I mean, one might be a little cheaper than the other, but it might not wear very well. So I set up an experiment. So I'll start with brand A. I'll set up the number of months before it starts to wear, and I'll run some tests on maybe some boards. Okay, my first test lasted 34 months. So I'm going to kind of set up a bar graph with paint cans. My second test lasted only 11 months. My third lasted 78 months. And here's a representation of 3 more added for a total of 6 tests. And I wrote the number of months over the top that they lasted. But you can see that this information ranges from 11 to 78. So the range here, the range of a data set is highest to lowest. So 78 minus 11 equals 67 months. So our range is 67 months. Okay, let's compare this to the next brand. And here's how brand B worked out. I wrote the number of months over the top. There was two test cases where they lasted 34 months. Again, we'll use range here, and the range of our data for brand B is 12 months. So quite different from brand A. So let's do some calculations here using what we know. So for the first set, brand A, if I calculate the mean, the median, and the mode, I get 34.7, 34.5, and 35 respectively. For the second brand, if I do these same calculations, I get 34, 34, 34 across the board. So based on our central rules, central tendency rules, looks like brand A is the better brand than brand B. But would you necessarily say this? I mean, if you go out and buy brand A, you just might end up with a can of paint that only lasts 11 months. So if we take a first look at the range and we compare the ranges, it looks like brand B, the range of information, is actually less than brand A. So that might be useful for us. However, that doesn't really tell us much about what's going on in between the left and right side of the range when we look at a range. In order to do something like that, we're going to need to do something a tad more complicated probably. What we really want to do is we want to compare ideas about how our data points vary from the mean. We want to come up with a way of describing that. So here I set up a frequency distribution. Well, I set up the information over here. I haven't actually set it up in a frequency distribution. But here's the data from lowest to highest for brand B, 28 months being the lowest, 40 months being the highest. So let's look at some information and see how it varies from the mean. So let's take the value of B and subtract off the mean. We could do it the other way around, I suppose, but let's do it this way. So 28 is our value, minus 34 for the mean, equals minus 6. 30 minus 34 equals minus 4. 34 minus 34 equals 0. And I can continue with the other three. Again, 34 is 0. 38 minus 34 is 4. And 40 minus 34 is 6. So minus 6, minus 4, 0, 0, 4, and 6 are how our brand varies from the mean. Well, what can we do with this information? That tells us a little bit about each individual, but we want kind of like one value that gives us a sense of how this information is varying. Well, we could add all these all up, so I get a total. But you can see minus 6 plus 6, minus 4 plus 4, 0 plus 0. The total is going to equal 0. Well, that doesn't tell us a lot. Well, maybe what we ought to do is get rid of these negatives somehow. And what we could do to do that is we could take this calculation we made and we can just square it. If we square it, it's always going to be positive. So if we take minus 6 squared, that's 36, minus 4 squared is 16, 0 squared is 0, 0 squared is 0 again, 4 squared is 16, and 36. Okay, now we have all positive numbers. So it's a positive squared distance from the mean. So let's total all these up. So if I total all these numbers up, my total squared difference is 104. Well, let's now convert that back into the square. Let's take the square root of that. So we go back down to, so square root of 104. Well, actually, before I do that, let's find our average square distance, which is going to be 104 over 6. And we come up with a value of 17.33. This, in fact, is something we call the variance. This is the variance of our data. Often we represent this 17.33 with the Greek term, say, sigma squared. Now, since this is a squared term, we want this term on the same order as our monthly terms. So we define standard deviation then as just taking the square root of the variance. So the standard deviation is just sigma. And that equals 4.16. So for brand B, the standard deviation is 4.16 months. So that's like 4.16 on either side of our mean of 34. One standard deviation, 4.16 on either side of 34 months. Well, let's compare that to brand A. So if I do the same thing, setting up my table, take my mean or my value for each of the paint can data points for brand A and subtract off the mean, I get these values. If I square that, I get these values. If I add those squared values all together and total it up, I get 2825.34. And then when I divide it by 6, I get 470.89. This is our variance here for brand A. And this is our standard deviation if I take the square root of that. And so for brand A, I get 21.7 months as my standard deviation. So that's an indication of how the paint cans vary. The number of months they last vary. So based on that analysis, clearly you probably want to choose the paint can that varies the least, so you have a better chance of getting a can of paint that performs in a way that you expect it to perform. So even though brand A has a higher mean, higher median, brand B has a lower range, which means the cans are the performance is more mashed together, less spread out, and we can get a sense on how spread out it is compared to the mean by calculating our standard deviation. And brand B then has a standard deviation of essentially plus or minus 4.16 compared to 21.7 for brand A.